Hi everyone, welcome back to my Seurat video tutorials. In this video, I'm going to show you an important Seurat function, the subset function. So actually, in my video 4, when we perform the quantity control and select the cells for further analysis to merge the 3 single-cell RNA sequencing dataset, we already used this function to get rid of low-quantity cells. So today I'm going to show you how to use the subset function to extract cells from analyzed dataset. So again, we are going to use the integrated dataset from normal human lung tissue. So let's read this one into R. So we still use the low resolution 0.01 to reduce the cluster numbers. So we can use the dim plot to have a look the cell clusters. Let's zoom in. You can see again we just have 7 cell clusters with resolution 0.01. First, I would like to show you how to use the subset function to extract the subset cells based on the expression level of a gene. So we are going to use the SFTPB as an example to extract the type 2 epithelial cells, because SFTPB is a marker for type 2 epithelial cells in the lung. So we set the expression level greater than 4 for SFTPB. So let's run this function. So we name the SFTPB positive cells as type 2 epithelial cells. So we can use the dim plot to have a look at the new object, type 2 epithelial cells. So we can run dim plot. So we zoom in again. So you can see the majority of cells are from cluster 2. So they are SFTPB positive cells and they are type 2 epithelial cells. So we can also use another marker, CD52. So it is the immune cells marker to extract the immune cells. So we set the expression value greater than 2.8. So you can see from the feature plot for the range of this value for any genes. So let's run the subset function for CD52 with the value greater than 2.8. We can use the dim plot again to see the cells we extracted from the full data set. So we name it as the immune cells. You can see, we can zoom in again, you can see cluster 0, cluster 3, and cluster 5 are immune cells. So we use the CD52 as a mark, extracted the immune cells. So here we extract the cells based on the expression level of gene, but we also can subset cell clusters by the cluster name. So we know cluster 0, cluster 3, and cluster 5 are immune cells. So we can use the subset function with the idents argument to put immune cells cluster in here. Then we can run the subset function. We can extract cluster 0, 3, and 5. So we can run it again. Let's run the dim plot again. Let's zoom in. So now you can see we extract more cells from cluster 0 and cluster 3, because when we use the CD52 two genes with the expression value greater than 2.8, so we get rid of some cells from those canisters. So here I show you how to subset more than one cell canisters. In my next demonstration, I show you how to subset one cell canisters. So we know canister 4 are mesenchymal cells, so we can just subset one canister cells, canister 4, to extract mesenchymal cells from the whole data set. Let's run this function. We can run dim plot again. You can see we extracted the canister 4. We know they are mesenchymal cells. So the subset function is very convenient to extract the cells you are interested in a tissue. So in this case, we are extracting mesenchymal cells from the non-tissue. So when you analyze the dataset for the whole non-tissue, it is very hard to identify subgroups of cells. For example, in the mesenchymal cells group, we have fibroblast, parasites, and smooth muscle cells. So we can subset the mesenchymal cells population from the whole non-tissue data set, then reanalyze it to identify the subgroups. So we got the population of mesenchymal cells now. We can reanalyze it to identify fibroblast, parasites, and smooth muscle cells. So when we run the subset function for canister 4 mesenchymal cells, we created a new Seurat object named as mesenchymal cells. So we can just run the standard workflow for cell clustering and visualization for the new Seurat object mesenchymal cells. So I introduced the standard workflow in my previous video. If you haven't watched it, you can go back to watch it. So the first step is to scale the data. Next, we run linear dimensional reduction, run PCA. Then we find the labels and the canisters from the mesenchymal cells Seurat object. Finally, we can run UMap to place the cells in lower dimensional space. So now we can visualize the cell canisters. Let's zoom in. You can see with a resolution 0.1, we got 4 cell canisters here. So we can use the feature plot with the cell type specific marker genes to identify fibroblast, parasite, and smooth muscle cells in this mesenchymal cells object. So we know PDGFRA and NUM are fibroblast specific marker genes. DES is a marker gene for smooth muscle cells, and RGS5 is a marker gene for parasite. So let's run this feature plot function. So we can zoom in. So you can see PDGFRA and NUM both label canister 0 and canister 1. So they are fibroblast. So DES labels canister 3. So canister 3 are smooth muscle cells, and ArcGIS file enables canasta tool, so we know canasta tool are parasite. So I'm going to stop the demonstration today. So in summary, I showed you the subset function, and it is a very useful function to extract cells that you are interested in your dataset to do further analysis. So we can save the mesenchymal cells Seurat object. Then we can use it in our upcoming video tutorials. So please subscribe my channel if you would like to watch my upcoming video tutorials.